Yeah, I'm here to talk about a pretty heavy topic, complexity. Specifically, we want to remove complexity. We're going to peel it away. So for those who don't know me, my name is Mitchell Hanberg, go by Mitch. Really happy to be here. I woke up yesterday morning with severe back pain and was at the point of, do I call my dad, who's a doctor, and beg for some drugs, or do I have to skip? But heavy regimen of Tylenol and Advil got me here, so I'm glad to be here. I work at a company called DraftKings. I'm on the expert core team. It's the official language server for Elixir, and been working at Elixir since 2017. Went pro, as I say, around 2020. So, yeah, pretty technical topic coming from Maggie. It's going to be hard to follow, but hopefully I'll be a comparable orator. I thought I was listening to an audiobook during it, so here we go. So, code bases, they often start as like an idyllic bastion of hope, started by 1 to 2 people, usually like architect or staff engineer. Or alternatively, they sometimes start as a prototype you wrote in the weekend and you ship to production and you've been battling it kind of ever since. But if you're successful after a time, many people will have worked on your original, bastion of hope there. But this idyllic playground of code quickly degrades into something scary sometimes, a dungeon. Your code base turns into a dungeon filled with endless corridors, trapdoors, and monsters. Joining this project takes courage. At best, you have a graybeard on the team who knows its treachery. At worst, you have cryptic Git commits leading you astray. So let's walk through this metaphor a bit and connect to it more deeply about our code base. So every program has an entry point. This is when you enter the dungeon. When you first started learning programming, you probably dealt with C or Java, and you have your main function. With us who write a lot of web applications, your controller action might actually be the entry point to your code base. Could be a WebSocket frame, or a Kafka RabbitMQ message, or even like an Oban job. Function calls are basically a staircase leading you deeper into your dungeon. Side effects might give you a peek to the outside world, letting you escape the confines of this dungeon. Often barred with iron, these windows give you false hope. The dreaded false layer, you're exploring and you think you found a useful pathway to figure out what's going wrong. You descend just to find an empty room with a dusty, pilfered chest. Indirection, self-explanatory. When exploring the code base, indirection might lead you down the wrong path. Sometimes the wrong extraction will lead you to a monster rather than bring you to a campfire. A dungeon is scary, and many brave heroes meet their fate inside of them. The royal messenger, pager duty, calls you to arms late at night, only to wander aimlessly. But fortresses are strong. With a little spring cleaning and self-care, we can slowly transform any dungeon into a fortress. When pager duty calls upon us, we'll be confident in our ability to navigate our stronghold and destroy the invader. So, peeling away complexity. Complexity means a lot of things to a lot of people. What is it? In my opinion, this complexity that we're talking about is code that is hard to read, debug, and change later. Peeling it away is about transforming a perilous dungeon into our fortress. So let's examine some characteristics of code bases that might lead to complexity and ways we can combat it. Deep stack traces. A deep stack trace can be a cause of hard to follow code that is hard to change. If you're changing on something works, you might find yourself wandering through 15 files and 25 function calls before you find your answer. Maybe you also use this function in multiple places, but you need slightly different behavior, but it's something that's deep down in the stack trace, so you have to thread these options all the way through. When you do that, oftentimes you break a whole lot of tests. You end up adding default options parameters to everything, even though some of the functions don't really use it. And everything gets tricky. We have uncontrolled side effects. So side effects in this context are really just anything that reaches outside of the calling context of the function. So you're putting something or getting something from the database, you're reaching out to the beloved user service, HTTP call, you're even getting something from application config, that's global state, or just process state in your application supervision tree. It's uncontrolled when side effects just seem to sprout anywhere without really any thought. You're like, oh, I need this value, I'll just make an HTTP request right here without really thinking about it. Side effects are usually mocked, but if you have them everywhere, testing becomes extremely tedious. False layers that don't add any value and generally become a distraction. A function call that just calls another function with an option passed to it, and the name is like create new active thing, rather than just passing active to your thing. We'll take a look at that. These functions generally are pointless when you're trying to debug. It's just confusing. Or like functions that call a function and then they pattern match on the error message and just tweak it and kind of change it out of the blue. Indirection. In Elixir, we kind of abuse behaviors for the sake of mocking. This kind of indirection makes debugging extremely difficult. If you've ever run into a module attribute called something underscore impl, you really know what I'm talking about. Don't hate me for this, but def delegate considered harmful. There could be other kinds of abstractions that make things more difficult to understand rather than easier. So it's kind of dive into deep stack traces. The entry point of your program is like a great place to coordinate work. So flattening a stack trace can help with flexibility and composition. And from now on, we'll just, if you see DST, doesn't mean daylight savings time, it means deep stack trace. Add it to your lexicon. So here's a very boring example, but we illustrate what I mean by deep stack trace. We see on the left that each function calls another function, and the run function only calls one of them, and it just goes down and down and down. On the right, we shorten our stack trace, our deepest stack trace, by coordinating this work in the run function at the top and decoupling the responsibilities of all the lower functions. To illustrate a further problem with deep stack traces, when you need to pass something down, like for here you can see the BAS function needs to use some piece of data, but to get it, you need to pass it all the way through from the top. You may have heard of this called like prop drilling, kind of in the React like front end world, kind of a similar concept. With a flatter structure, we can just pass it directly to the function that needs it. You can see on the right, BAS is being called at that top level, and we can just pass that right in. Now, to avoid prop drilling, programmers might just reach out the window from deep inside the stack trace by a side effect to pull the data they need. Often people newer to functional programming might produce this. They might stick something in the process dictionary or agent so they can avoid proper functional programming. We can see here on the right, our worst example, we're calling a side effect deep down in there. So kind of take a look at our to-do application in our dungeon version of our code base. So here it looks very normal. This is like straight out of like what the Phoenix generator might create for you. We call our create function there, and we render the thing down to the user. Inside the create function, it looks fairly standard, but so we pass our params to our change set, and then we pass it to a function called insert and broadcast. That's a little different, but let's dive into the change set first. In the change set, it looks like our API accepts a name for a category, but we need a richer data structure. So we call this function called getCategory in the categories module, and we put that inside the params there. So if let's take a look at that, we see, okay, the categories module actually just delegates to the category cache with a slightly different name. Okay, we got to jump through there, and we get to our cache, and okay, we see it's the cache cache. And if we don't, if there's nothing in the cache, we reach out to something called the category client to get our category from the category service. Here we see, okay, we've got a rec call here to reach out to the category service. And these are two side effects. The cachex and the rec call are both side effects, and they're both extremely deep in this stack trace and very far away from our boundary at the entry point. And you might be thinking, this seems really contrived. This is not contrived. This is a very loosely renamed example I've seen in a real code base at a former job. So here's kind of an overview. It's a mind map I had built to kind of help build out these scenarios. I think this is readable. So here we can see kind of the entry point into our dungeon. We've got our controller, we call our create, we call our change set, and then up there, the blue ones are side effects, and the red is a false layer. I mean, you can kind of just, this is mostly to show you like how deep you are when you're looking at this and where the side effects are. Now let's kind of look at what our dungeon could look like after a little cleaning. It's starting to look a little more like a fortress. Here we have our categories get category function, but it's actually pulled up to our entry point in the controller action. And once we get our category, and we only want to make our to-do if we can get this richer data, so we don't even attempt to call the create. It just seems a lot more, once, like the other thing seems pretty sensible until you see something that is a little better. And we can look at the mind map of our exalted fortress. So we can see we've flattened the structure quite a bit, as well as brought those side effects closer to the top. So let's now discuss those side effects a little more in depth. So uncontrolled side effects. In the previous section, we saw our examples of potentially uncontrolled side effects, our category cache and our category client. We'll call this use now. It's a new word for your lexicon. So let's re-examine the code for clarity that we saw before. We have a category module that delegates to the we have a category module that delegates to the category cache, and the category cache module is trying to get it from the cachex cache. If it doesn't exist, call the category client module. This module will make an HTTP request to fetch it from the category service. So our cleaned up version, we pull our side effects up closer to the entry point. So here in our get category functions we called in the controller action, we have some of our same behavior here, but instead of our cachex, our category get category cache function being responsible for calling the category client, here we're kind of lifting it all up into this one situation. So we can also use value-based dependency injection to make this more testable. Instead of hard coding the cache or the URL for the HTTP request, we can pass them in. Very functional programming. These can be set inside a plug for a Phoenix controller, which we'll take a look at, but there's usually something analogous to a plug in other frameworks or contexts, or if there isn't, it's very easy to kind of facilitate something like that. So to make our code more testable, especially in an async context for our tests, because we want to have async true for all of our tests, we can pass the cache and the rec client to these functions for them to use rather than using a hard-coded one. So here you can see we pass our cache through and our client. The client has a base URL, so we don't have to have the whole thing there. And you see where we pass them through in the get category function. So the tricky part about this is where do you actually decide what value to use for your cache? In the context of a Phoenix HTTP request, the controller action is our entry point. Here we can easily fill in our inventory with our caches and clients from a couple simple plugs. You notice here that we fetch our cache and the client from the private field in the plug connection struct. This is a place for libraries and frameworks to store values they might need without polluting the assigns, and we can utilize it as well. If we take a look at one of these plugs, We're simply putting the default value for the rec client into the private field if it isn't already there. In our test, we'll manually set the client to the one we're using for that test. That's how we achieve our value-based dependency injection. And there is a function on the plug.con module called putPrivate, but it doesn't handle kind of the put new, so we just kind of manually do it here. So our test before, you've probably seen this in a lot of places. We have our async false, because we're going to be touching some global state. And here, the way we're kind of configuring, I guess I'll note, in this kind of test, we're mocking the HTTP requests with this library called test server. It's very similar to bypass, where it boots up a little instance of an HTTP thing and you set expectations and whatnot. But you have to align the port of that test server with your HTTP client. So in the past, the way you might have done it is you're configuring this in your application environment. You want to get the original one. You want to put the new one in there. And then on exit, you want to reset it so it doesn't mess with other tests if you're actually using a different port or whatever. But this has to be a synchronous test, cannot be async, because it's globally changing that application config, and another test module could also be changing it, and you'll have race conditions, and you'll be pulling your hair out. Our improved tests are able to start its own cache and rec client per test, and we simply pass them into the controller action via the private field on the plug connection struct. This way we get a cache per test because like a cache x cache doesn't necessarily have like your Postgres ecto sandboxing that you're used to, so you don't want to use the global one because that's global state. You want to start your own, get your own rec client that's hooked up to hit your test server, add your expectations, put them in there, you're good. This is just a complicated way of, because the post helper there from the Phoenix controllers is basically just like your function here, but you're just not used to calling it that way because you didn't really write it. But in its parameters, in this sense, is that private field in the struct. So you can put them in there, and you can run all your code asynchronous, and you have full control over it all. So value-based dependency injection makes writing these tests better and faster, but it can still be a pain if you have side effects deep in your stack trace, because let's say you're testing this at the controller level, you have to add your test server mock, but then you're also going to test your to-do.create function. Well, that also calls the HTTP thing, so you got to, when you test that, you have to mock that, and all the way down, so you end up mocking the same thing like a bunch of times. But by pulling our side effects up closer to the boundary, we avoid passing that context all through all that function, so we can only run it in the places that need it. Global processes and application config are examples of global state that I think people often miss, and it's effectively a side effect when you're reaching out to grab stuff from them. So try starting processes per test instead of starting them for your whole test suite, because by default it starts your whole application supervision tree, so your default caches and everything will start there. So we also have slightly different database techniques for this, because the database is typically a side effect, but we normally tolerate that because it's so core to our applications. We're going to hit a real database, and we're able in Elixir with Postgres and Ecto to effectively have a sandbox so we can still run async tests that don't clobber each other. But this can break down when you're testing using global processes in your application supervision tree, because you might have like a RabbitMQ consumer that is a little too laborious to set up every test, so you just still want to run it through. That process doesn't really have any expectations that you need to configure per test. You just need to run it through it. But because it's a global test or global process, it's not synchronized with your test process, so the Ecto sandbox can't align everything, and you end up having to make your test synchronous. But we can avoid this by passing the sandbox metadata around to get it into hard to reach places. This is how the Wallaby testing framework works. It puts the Ecto sandbox metadata in the user agent and sends it up, and then in your endpoint, there's a special code that pulls it out and says, okay, this process and this process are sharing this database connection, so they can run concurrently. And you can also just kind of do this yourself in other contexts with a little bit of effort. I wouldn't say it's like, it kind of feels bad while you're writing it, but in the end, it ends up pretty good. I have an example on my GitHub called Sand Rabbit. It showcases kind of how to activate the sandbox with a cache cache and the database that's pushing messages through a RabbitMQ kind of global gen server consumer, and will also touch the database. So false layers, I've seen a couple of false layers in these examples, but not all short functions are necessary false layers. You shouldn't just inline everything. We saw this before, and this could easily be flattened kind of closer to the entry point. This is a false layer because moving this to a function doesn't really add clarity or hide unimportant details. It's actually just hiding the important details of what you want. But a more flagrant example is like this random helper function. It's not really any more informative than calling this code as it is, like inlining it. You know you're getting active to-dos. But not every, like I said, not every short function can be a false layer. So in a case like this, we just basically make our own cache module, and then just like this could almost be an actual good use case of def delegate. But so like a module like this might also have child spec for the cache to get started. And a lot of times you're trying to think, oh, what types of things do I have in caches, and where am I getting those things? And it's a lot easier to say, I want to find all category cache accesses by looking for this function references in your code base. So in that scenario, it's can be worth it. So indirection. Elixir applications often abuse behaviors to achieve test mocking with mocks. I'm not a huge fan of mocking outside of using like HTTP, like bypass test server type things, but sometimes you have to do it. But this creates a ton of fake indirection because behaviors are actually a form of an abstraction. Fake indirection that makes navigating and changing your code base harder. We can leverage techniques to avoid fake indirection though. We come to this code, we're hoping to trace how the messages are getting published onto RabbitMQ. We arrived to find some indirection, a sign telling us that we want to actually, well, we wanted actually elsewhere, but it's not really giving us any real help. So at the top, we see our module attribute that's fetching, assumably, a module out of application configuration. So we'll jump into our application configuration. We're in prod.exs. We see, okay, there's a todos.rabbitmq.impl module here. So we go looking for that module. We eventually find it, but it kind of took a while. We searched for the word impl, and it showed up in a million places. And then we looked for rabbitmq.impl, didn't see it because of the way it's defined here, but we eventually find it. And we can see here we've got our behavior here, and somewhat confusingly to me, the modules that have the callback attributes are the behaviors, and the one that says behavior is the implementation of that behavior. So here we basically find it, and it's really just not interesting at all. We did all that work to find what's kind of going on, and it's just kind of faking it out so you can switch out implementations at test time. So in cases like this, I believe you should actually just run RabbitMQ or Kafka, whatever, when running your tests. It's basically just as important as running your database, which everyone does, and it kind of removes the need for this indirection. So kind of start wrapping things up, the key concepts that I wanted to share with everyone is flattening your call structure can improve composition and testability. Executing side effects closer to your entry point helps testing and reduces surprises down the line. False layers are generally a distraction. And indirection done for testing purposes adds more problems than it solves. So from dungeon to fortress, little by little, even one hero can transform a dark and dreary dungeon into a stalwart fortress. But fear not, if you have a particularly dangerous dungeon, You can chip away at the monsters over time. As conditions improve, fellow heroes will start to proliferate your improvements as well now that you've lit the path for them to follow. Thank you.